Welcome to students and viewers. Here we will discuss a few sums on logarithm. You remember the definition of logarithm we discussed earlier. If a to the power x equal to b, then in terms of logarithm we write it as log b to the base a equal to x. Logarithm of a given number is the exponent of another number, which is called we call it base, and base must be raised to the exponent so that it becomes equal to the given number. So what is the logarithm of 625 with respect to the base 5? That means 5 must be raised to an exponent so that it becomes equal to 625. So to what exponent 5 must be raised so that it becomes 625? You see, 5 to the power 1 equal to 5, 5 to the power 2 equal to 25, 5 to the power 3 equal to 125, 5 to the power 4 equal to 625. Therefore, 5 to the power 4 equal to 625. So we write it as logarithm of 625 with respect to the base 5 equal to 4. That means 5 has to be raised to the exponent of 4 so that it becomes equal to given number 625. Now you know that a to the power 0 equal to 1. So in terms of logarithm, we will write it as log 1 to the base a equal to 0. Right? Similarly, a to the power 1 equal to a, that means log a to the base a equal to 1. Just you imagine this formula, a to the power x equal to b. Now in terms of in place of x you substitute 1, so you got log a to the base a equal to 1. These two things you can remember as a property of logarithm. Now we will try to solve a few numericals on logarithm. Suppose you have to find the logarithm of 27 with respect to the base 1 by 81. What is logarithm of 27 with respect to the base 1 by 81 equal to what? This is question number 1. That means 1 by 81 to the base x equal to 27. Now we have to find x, right? So 1 by 81 means, let us try to solve this. 1 by 81 means 81 is 3 to the power 4 to the base to the power x equal to 27. This you can write it as 3 to the power minus 4 to the power x equal to 3 cube. So you can write it as 3 to the power minus 4x equal to 3. That means minus 4x equal to 3, x equal to minus 3 by 4. Right? Therefore, we can write it as logarithm of 27 with respect to the base 1 by 81 equal to, answer is 3 by minus 3 by 4. This is the answer. Now let us do some more exercise here again. Write in exponential form. Question number 2 say write in exponential form. Exponential form. You are given that logarithm of 0.125 to the base, say 10 equal to minus 1. Write in exponential form. This is 8. Right? Now you remember the definition again. A to the power x equal to b. So in terms of logarithm you will write it as log b to the base a equal to x. Now you compare this with this formula, log b to the base a equal to x. That means a to the power x equal to b, a to the power x. So in terms of in terms of exponential form, you will write it as a to the power x. A to the power x means a to the power minus 1 equal to 0.125. Right? So a to the power minus 1 means, what is a to the power minus 1? This is 1 by 8 equal to 0.125. So this is the exponential form of this logarithm. Again, suppose this one is given, write in exponential form log 0.01 with respect to the base 10 equal to 2. So in terms of exponential form, you will write it as 10 to the power, this is minus 2, 10 to the power minus 2 equal to 0.01. So in terms of exponential form, this is written as 10 to the power minus 2 equal to 0.01. Similarly, suppose you are given log 1 to the base 10 equal to 0. So in terms of exponential form, you will write it as 10 to the power 0 equal to 1. 10 to the power 0 equal to 1. Question number 3. Solve for x. Suppose you are given log x to the base 10 equal to minus 2. So let us solve this. This implies that 10 to the power minus 2 equal to x. So in terms of exponential form, you will write this 10 to the power minus 2 equal to x. 10 to the power minus 2 means 1 by 10 to the power 2 equal to x. You remember we studied it earlier in this chapter, exponents and power. A to the power minus m means 1 by a to the power m. If you write in inverse, the exponent will be positive. So what is x? Therefore x equal to 1 by 10 square means 1 by 100. This is the answer. Similarly, suppose b, this is given as log 243 to the base 9 equal to x. So let us solve this. This implies that 9 to the power x equal to 243. So let us do prime factorization. We'll try to solve this for x. 243, this is divisible by 3. 3 is 24, 3 1s are 3 into 27, 3 9s are 3 3s are. And 9 to the power x means 3 square to the power x equal to, we got it as 3 to the power 5. That means 3 to the power twice of x equal to 3 to the power 5. So comparing exponents on both sides, we got twice of x equal to 5. That means x equal to 5 by 2. This is the answer, right? Now let us solve this. Say this is given log twice of x square minus 1 to the base 27 equal to 2. We have to find x here. So let us solve this for x. First you will write it in exponential form. 7 to the power 2 equal to twice of x square minus 1. Again remember the property log b to the base a equal to x. So in exponential form you will write it as a to the power x equal to b. Right? A to the power x equal to b. So let us solve this for x. 49 equal to twice of x square minus 1. This implies twice of x square equal to 50, x square equal to 25, x equal to square root of 25, that means plus minus 5. Now there are two roots here. Let us cross check here. Check. So when x equal to minus 5, log 2 into minus 5 square minus 1 to the base 7 equal to log minus 5 square means 25, 25 minus 25 into 2, 50 minus 1, 49 to the base 7. So this equal to, answer is 2. Suppose log 49 to the base 7 equal to x, 7 to the power x equal to 49, that means 7 square, x equal to 2. And for x equal to 5, log 2 into x square minus 1 to the base 7 equal to log 49 to the base 7. So obviously the answer is 2. So both roots are correct answer. Next question is evaluate. Suppose you are given log 0.01 to the base 10. Evaluate this. Now let this log 0.01 to the base 10 equal to x. Now in exponential form you will write it as 10 to the power x equal to 0.01. This implies that 10 to the power x equal to 0.01 means 1 by 100. This means 1 by 10 square. So 10 to the power x equal to 10 to the power minus 2, x equal to minus 2. Therefore, logarithm of 0.01 to the base 10 equal to minus 2. This is the answer. Then you are given to evaluate this one. Suppose log 16 to the base 0.5. Evaluate this. So let us say x equal to log 16 to the base 0.5. Now in terms of exponential form, we will write it as 0.5 to the power x equal to 16. 0.5 means you can write it as 1 by 2 to the power x equal to 16 means 2 to the power 4. So we will write it as 2 to the power minus 1. 1 by 2 means 2 to the power minus 1 to the power x equal to 2 to the power 4. This implies that 2 to the power minus x equal to 2 to the power 4. That means minus x equal to 4, x equal to minus 4. Therefore, log 16 to the base 0.5 equal to minus 4. This is the answer. Right? Now let us take the next question here. Given log x to the base 2 equal to m, log y to the base 5 equal to n, express 2 to the power m minus 3 in terms of x. Express 5 to the power 3n plus 2 in terms of y. Right? So given that log x to the base 2 equal to m, so in terms of exponential form you will write it as 2 to the power m equal to x. Log y to the base 5 equal to n, so 5 to the power n equal to y. Now we have to find express 2 to the power m minus 3 in terms of x. Now what is 2 to the power m minus 3? Equal to 2 to the power m divided by 2 to the power 3. You remember this property, a to the power m divided by a to the power n equal to a to the power m minus n. So a to the power m minus n means a to the power m divided by a to the power n. Now 2 to the power m divided by 2 cube. 2 to the power m means x. 2 to the power 3 means 8. Therefore, we express 2 to the power m minus 3 in terms of x. So in terms of x, answer is x by 8. Again, express 5 to the power 3n plus 2 in terms of y. Now let us see 5 to the power 3n plus 2 means 5 to the power 3n into 5 to the power 2. You remember the property, a to the power m into a to the power n equal to a to the power m plus n. So a to the power m plus n means a to the power m multiplied by a to the power n. Now 5 to the power 3n means 5 to the power n to the power 3 into 5 square means 25. Now what is 5 to the power n? This is y. So y to the power 3 into 25. So this is 25 y cube. So we express 5 to the power 3n plus 2 in terms of y. In terms of y, answer is 25 y cube. Next question is, if log x to the power 2 equal to the base 2 equal to a, log y to the base 3 equal to a, write 72 to the power a in terms of x and y. So you are given that log x to the base 2 equal to a, that means 2 to the power a equal to x. Again, log y to the base 3 equal to a, that means 3 to the power a equal to y. In exponential form, we write it as 2 to the power a equal to x, 3 to the power y a equal to y. Now 72 to the power a means, what is 72? Let us do prime factorization here. 72 you can express in terms of 2 and 3, maybe 2 into 36, 2 into 18, 2 9 ja, 3 3 ja. So 72 if you express in terms of 2 and 3, you will write 2 cube multiplied by 3 square to the power a. This implies 2 to the power 3a multiplied by 3 to the power 2a. Or you can write it as 2 to the power a to the power 3, 3 to the power a to the power 2. So what is 2 to the power a? This is x. So x cube multiplied by 3 to the power a means y, y square. So answer is x cube y square. So we write 72 to the power a in terms of x and y. So thank you viewers for watching my video. Please do not forget to subscribe my channel. We will discuss some more examples and properties of logarithm in the next class again. Bye bye for now.